Hello and welcome to Tattva Conversations and Explorations. For our fifth episode, we sat down with Dr. Siddhi Pathak, who works as an assistant professor at the Chennai Mathematical Institute in Chennai, India. Her research interest lies in number theory, especially the theory of L functions, modular forms, and elliptic functions. She completed her Ph.D. under the supervision of Professor Murty at Queen's University in 2019. Dr. Pathak talks about how a lack of familiarity with the language of maths can turn maths into something scary instead of something beautiful, and some of the ways that she employs to make that language accessible to her students are through puzzles and stories. She believes that stories of mathematicians can help students build a bridge towards maths in a way that is not possible through cold textbook mathematics alone. She also shares how maths has helped her train her mind to deal with difficult life situations. We hope this conversation can help the listeners see maths as something beyond the textbook, beyond the fear, beyond a sense of inadequacy, and see it for its tattva, its true essence, and for the intricate tapestry of numbers, symbols, theorems, which when closely observed by the student, provide new ways to see the world and ourselves. Hello, Dr. Siddhi. Welcome to Tattva.
Hi, Disha. Thank you.
Thank you for taking out your time to sit down and do this interview with us. So I think I'll just, it's best to just get started. Sure. Right? And let's see how it goes. So my first question to you is, what does math mean to you?
So math, okay, I've been doing math since my childhood actually. And what it means to me is a very, I think, a transcendental question because it's difficult to describe in words. I mean, it's the similar kind of relationship that art has for an artist. I mean, it holds a special place in your life. It is something that I am lucky to do as my profession as well. But it's not necessary that it has to be your means of livelihood in order for me to enjoy it. I think it has helped me in various walks of life. Yeah, overall, I think it's just a very special relationship that it's difficult to put it in words.
Okay, we'll try to explore it because this is something that I've noticed in a couple of mathematicians that we've been talking to now for a while. They definitely talk about a relationship that they share with the subject.
Yeah.
Right? They share a
Yes.
relationship with the subject as if it's a person, as if it's something they can relate to. They can interact with. That's certainly happening on some level. I understand that. But before we get into that, I would like to understand from you what is this sense of do you experience a sense of beauty, like you said, what art is to artists? That kind of comparison, it's common apparently among mathematicians, but it's very uncommon among non-mathematicians. So if you can walk down that path, like why that comparison? What's the beauty in math that you see that attracts you?
So it is very common for us to think about math as art or even music, for example. So it's something that you indulge yourself into and then you start enjoying it. So I think beauty, as you say, comes through patterns. And in art, we see that beauty through a certain pattern that you click with. Like the pattern that you click with might not be the pattern that I click with. So the art that you like is not necessarily the art that I like. Similarly with music, and I think similarly with math. There are math. I actually don't know what non-math people think about math, but for me,
they're downright afraid. In case you didn't know.
Okay. No, I know that they're afraid, but what I don't know is how do you picture it? Do you just see haphazard numbers and alphabets? all over the page, or the way we see it is we directly see the structure in it. Like we so once you are accustomed to the language, then I think you are ready to appreciate what the structure reflects. So for example, in music, until we know some basic language, or even literature, for example, unless we know the basic syntax or the script, it is difficult to appreciate the beauty in a poem, right? So I think with math, people who don't know math or are afraid of math, for them I think it's the language, the familiarity with the language that is missing. Once you develop that or you cultivate that, then seeing the beauty aspect becomes very clear.
How
And
nice.
yeah, and for me, so the way I first got accustomed to it was through solving puzzles and so on and so forth. But at this level, I think one way that you can see beauty would be through certain formulas, and something that you would not have expected a priori comes up as an equation, or comes up in the course of your research, and that somehow is the beauty.
Is
It
it in the form of a discovery? Would you say something that you've discovered, like maybe discovering a connection, not just as an answer, as we would, most of us would think, okay, I got the answer, but for you, maybe discovering something like a connection, a hidden pattern is.
Yes, yes, exactly, exactly. So I think that is what also leads to this feeling of happiness or joy that comes from this unexpected, not just a connection, but it's like an unexpected truth that you stumbled upon.
Wow. Okay.
And so the way there are a few theories that are for and against this, about whether you invent math or you discover math. But for one way of trying to understand what we do would be that like there are physical structures, there are axiomatic structures in the sort of mathematical universe, and then using certain tools we are trying to gauge how the structure is. So it's not the physical world, but it's sort of the mathematical world that we are trying to explore. And then in exploring that, you suddenly come across a certain, I should come up with a different word apart from connection, but a certain
Revelation.
structural pattern, a structural pattern. So and just as you discover that, that's where you see the beauty, that
Right.
in even in these inanimate alphabets and numbers and symbols, when they form the structure together and you come across it, that structure gives it the beauty.
How nice. So I have heard of this. I'm sure you have too heard of this phrase called "truth is beauty." Truth is beauty.
Beauty, yes.
So
Yeah.
when we had a philosopher of mathematics in as one of our early guests, and he said this because he also brought up the axiomatic world of which is the foundation of all mathematics. And in fact, just to go back a little, when I was doing my research before we started conducting this, it really struck me hard that we are basing all of math, and math is about precision, measurement, getting it right, to the point. It is based on these axioms, which are man-made. Euclid's axioms, or these are man-made axioms. So how is something that has been man-made creating this world which is apparently truthful? So what he said is that although these foundations, these axioms are invented, and apparently some new ones also are being developed because the old ones are being challenged, but the truth that they help you discover are proper objective truths. It's, yeah. So I found that it's exactly what you said. And going back to this word, when in your first answer you used a lot of wonderful and beautiful words. You used the word beauty, you used music, you also used the word transcendental. transcendental. That was your first word. Now this word, it just takes me back to this film, The Man Who Knew Infinity. I've quoted it a dozen times in these podcasts. In that, Srinivas Ramanujan says this, that a number or mathematics itself means nothing to me unless it expresses a thought of God. So I think we need to also establish between us, at least you and me, like, what does transcendental mean to you? Is it something to do with the divinity as we Indians understand it, with God as we Indians understand it, or is it how do you approach it? Why would you use that word? We had Professor Ramurthy, we had Dr. Ashna Sen, and they are talking about numbers and then the powers in these numbers. Like, for example, the number 1279, which is the number of enlightenment,
1729.
right? 12 to the power of 3 plus 1,
1729, yeah.
right? So these numbers, and we have the Gayatri Mantra, we have the 10108 number of times we chant things. So can you please elaborate on the transcendental nature of things as you understand it from your point of view?
So, from my point of view, the choice of word transcendence was very natural because my research revolves around something called transcendental numbers. So, since I am so familiar with it, the word transcendental was the first thing that came out of my mouth very, very instinctively. But the way I mean it is not through divinity or spirituality, but rather. So the reason I used transcendence was to describe my relationship with math, and the reason I used transcendental there was to signify that it is not something that I can put in words. It's just something that is, and that is something that I am enjoying at the present moment. But it is not something that I can put in words. So in that sense, I use the word transcendental. But the point that you brought up was about man who knew infinity, and where Ramanujan says that every formula is an expression of God. I think one should understand that from the perspective of uh, his own spiritual upbringing, as well as his state of mind at that time. But I, I personally don't see it as being, oh, so it's not something where you close your eyes, you dream of something, and then you write it down. It's not something where he got the formula from the goddess and therefore he wrote it down, but rather that he was so involved in trying to understand it that it came as naturally as the truth of God for him. So I think it is from that perspective that one should take his statement rather than some supernatural aspect to it.
Yeah, it was his deep involvement with it, constant and deep involvement with it. Okay.
Yes, and I think since I keep on coming up with this, I think it's something similar that happens with an artist, right? Where they try to depict something on a canvas and they are trying to do it, and they get so involved in it that even in their dream state, they are thinking about their art or they're thinking about their painting. So I think that happens with everybody who is very much involved in their creative activity and is not particularly special to Ramanujan or to math or just one subject.
You're right, because I can't recall now, but I was listening to some mathematicians. Most likely it was a mathematician from the UK, Katie Steckles, Dr. Katie Steckles, and she gave the example of one female mathematician who would be so involved. I think I'm getting this right. I remember the example, I don't remember the name, that who got so involved with her math that before sleeping, she would just, draw some numbers or figures or formulas in the air with a finger and go to sleep. And something happened that more often than not in the morning when she'll get up, something would have rearranged itself and she would have a revelation of some kind or some inkling of a direction in which path to move. Okay. So I don't know what's going on, but you're right also that it is common across people who are involved with it. It could be any subject, it could be any idea, it could be maybe a problem at home, and if you're just really involved with it, either it can push you also in a corner sometimes when you're like really. Do you think that can also happen, right?
It can happen, I think so. And so, another thing that is important is to also create a little bit of a distance and let your subconscious mind do the work. So, if you consciously keep on thinking about I mean, this happens with our research questions very often, that you think about a problem and you try different ways of solving a problem and nothing is working. And then you realize that if you keep on going, then you are going into loops. You are doing the same thing again and again in different directions. And at that time, it is important to step back and tell yourself that, okay, I need a little bit of a break. And in that break, just not think about the problem at all. And I think it's not that if you stop thinking about the problem consciously, it does not mean that your subconscious stops thinking about it as well. I think it stays there, and that's and then in a moment when you are completely unaware, the solution may come up to you.
Magic.
I think the workings of a brain are still magical, as you say. But that happens even when you're trying to recall something. Let's say there is a particular fact that you're trying to recall, and then you try very hard to recall it, and it just is not coming to you. But if you step back and then just leave it, then suddenly it will come. You will remember what you were trying to remember. Uh, but sometimes just the very conscious process is not something that gives you the solution.
Right. So there is something called a mathematical way of thinking. Although I've also observed a lot of mathematicians, the contemporary mathematicians don't like to have this segregation between non-mathematicians and mathematicians. Where they're coming from is that if you apply yourself, then anybody can do math. Like anybody can do anything if you apply yourself, right? It's not just math is not for me. There is a reason why it is like that, if you're not applying yourself. So if you're applying yourself and then you develop this sort of a mathematical way of thinking, now there is rigor, there is discipline, there is maybe involving so much and then stepping back, like you were just saying. So are there is there this a certain kind of way that your doing math has influenced your thinking over the years, and if that way of thinking has helped you in your life, in your daily affairs, apart from in mathematics, has that happened?
Yes, certainly. So a mathematical way of thinking, meaning not just for mathematicians, a general way of thinking, I think. Mathematical basically means that you are applying logic and throwing away all the parts in your thinking that come from illogical concerns. So something that is, so for example, when you take a mathematical problem, the entities in that mathematical problem have to be completely well defined, and only then can you operate on them. So in our life, several times it happens that we feel stressed, and the main reason behind that stress comes from not understanding the definition of that problem. So just the idea that the problem exists gives you stress. However, if you actually try to apply this kind of mathematical way of thinking, that is, you try to understand what is the problem involved, what are the key aspects of the problem that are actually creating the problem, then you realize that at the heart of it, it's just one thing. And then once you take away all these layers and understand the heart of the problem, then more often than not, the solution is very apparent.
So in your own life, can you cite some examples where your mathematical way of thinking, or your way of thinking as doing math has influenced it, actually came in handy for you? Like you could find your way through a problem in your real life. Does something come to mind?
So I don't know whether one would call, I mean, I would try to think that my way of dealing with daily life issues comes from my training in mathematics. So, for example, so I was in my college, and I received a phone call that my mother is not well. And then just that one thing sort of tends to put you, yeah, tends to disorient you a little bit, and then you were like, okay, what exactly am I supposed to do right now? But then I think when I took a step back, and then I figured out that okay, this is exactly the problem with her, and then all I have to do is, send her to a hospital, and then myself I have to keep calm and then figure out how do I get to her. So then the next order of business of booking tickets, etc., and then reaching her on time. And then all throughout this entire process, making sure that neither her nor my father is uh, panicking about this whole situation. I think my mathematical training really helped me to deal with this particular situation, because I think it is very easy to get carried away by just knowing that someone so very close to you is undergoing a surgery for something regarding their health, and then that could lead to something very
Fatalistic.
yeah, yeah. However, knowing that okay, in this moment there is nothing that I mean, what it is, what exactly is going to help the situation, I think really made my whole life in that moment streamlined.
How nice. Yeah.
Yeah.
Thank God for that. And why do you think none of the other subjects did it for you? Or maybe they do it for others also, but there are other subjects as well that require a disciplined way of thinking, a concentrated way of looking, they can hone your focus. But why only math? What is it about math that you give it this credit for?
So actually, it's not just math. I think I have a lot. I have an interest in several other subjects. In my school, I definitely wanted to become a microbiologist, and then I definitely wanted to become a lawyer, and then I definitely wanted to become a dancer. But in the end, I chose math. I think one of the reasons that I found unique to math is that it it is immaterial of your uh, race or gender or age or uh, any other property of yours except for your thought. Whether you when you claim a theorem, if you have a correct proof, then it does not matter which corner of the world you come from, and it does not. I mean, there is no expert in the world who can say that your proof is wrong, because it is not an opinion. It is a logical. It's a logical process which is infallible. So it has that kind of. I mean, some people try to call it. Um, Being ice cold, like math is ice cold, in the sense that it does not care about anything else. It is just like if you are logically correct, it is correct. If your logic falters at any point of time, then your proof crumbles, and that's it.
Right. Right.
So there is this quality of math where you can check someone else's work, even if that someone is, let's say, a Fields medalist. If there is a fault in their proof, then there is a fault in their proof. That's it. It does not matter whether if the fault is found by a student, for example. So this quality of math is something that I don't find
A level
other
field.
subjects.
A level playing field.
Yeah, something like that.
Right.
And it's like it's a things are very well defined. So it does not matter whether what someone else's opinion of that particular
Got
proof
it.
is.
Got it.
It's
Got it.
just the truth is truth. And it
Right.
is well defined.
Right. So it is also very fascinating how some of these problems which become very popular in mathematics. Like, for example, I might be pronouncing the names incorrectly, but the Riemann hypothesis and some like Fermat's theorem. I don't know their backstory or anything. All I know is the longevity of the problem. Like, it has baffled mathematicians for long. Like, it has existed, I think, maybe for a century or longer, till someone comes along and finds a solution. So something grips the minds of a mathematician, that what is it, like they love the challenge of it. Something cannot be proved, and I think it's mostly for pure mathematicians, right,
Yes.
who have anyway devoted
Yes.
to their life towards understanding the idea side of math. So it's very fascinating to me. What are your thoughts on it? Like, what can occupy the mathematical brain for centuries, till, and you only rest in peace when you find, okay, here is the answer. You don't let go.
I so I think that is just the it's probably the type of people we are, right? I mean, if there is something that we think is true, so the whole idea of pure mathematics is to find logical proofs for truths. So we accept some statement as being true only when it can be deduced from the axioms in a logical way.
Yes.
Okay, so when in real life you come across a certain pattern, and
Hmm.
then you want to establish that pattern as being true,
Hmm.
then the only way of establishing that that pattern is true is by proving it.
Hmm.
Okay, so now if you see the pattern again and again, but you are not able to find the path to it from the axioms to the pattern, you're not able to find a path, then it is going to haunt you, right?
Right.
I mean, it is so sometimes it is something that seems so obviously true,
Hmm.
but you are not able to get to it through the axioms.
Hmm.
So it's like it is like, for example, you are walking through a dense forest,
Hmm.
and at the end of it, on a mountain, you see a castle.
Hmm.
So it is natural that for your own survival, you would like to reach the castle.
Hmm.
So what will you try to do? You will try to hedge through these dense forests and try to find a path, and you
Hmm.
won't rest until you find a path.
Hmm. Hmm.
And that is it. It's just similar to that. It's like you are in the forest of these ideas and this mathematical world, and you see a particular pattern which you think is true, and that is
Hmm.
like the castle for you.
Hmm.
And then you try your best to find a path of going there. And
Hmm.
then if you find the path, you survive. If you don't find the path, then God help you.
Or you stay on the other side of the dark forest, like us non-mathematicians. Don't you enter? So
Well, then you lose on the joy of finding the path.
yes, 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 yes,
So,
and I think one of the one of the ways to hack your way to that this place, this desired place, is intuition. Because I was talking to one teacher of mathematics again, and she told me that sometimes you have this inkling, an intuition about something being right, and you can kind of see it in the distance. It is formless, it's like smoke, it's not taken form, but you, something in your gut tells you it's there. And then you slowly, it could take you years, it could take you decades, it could take you a whole lifetime to get there. But intuition is so strong about something existing out there that you drop everything else that maybe that's too an extremist of a statement, but it haunts you. But you stay on
mhm,
track and you follow your intuition, and you follow it so much that you are sure of finding
mhm.
something that is still taking shape. Have you experienced these things where you're just led by your intuition, you don't give up on it, and you've been rewarded in the end for your patience and your faith?
And I think that is precisely the thing that keeps us going, because the problems that we come across in the research are often of the type where you don't know whether a particular statement is going to be true or false, but your gut tells you that it should be true, and then you set on the course of trying to find a proof. So you might try different approaches, and it might take you a lot of failures to get there. But
Hmm.
the joy that you feel after reaching there or after being able to prove that the statement is true is just so immense that you can set everything aside and give your life to just trying to prove that that statement is true.
Some people call intuition as the sixth sense. And would you say then that math has somehow also honed your intuition generally? Have you found yourself becoming a little more intuitive about things?
I think there has to be a little bit of a distinction between intuition and instinct.
Hmm.
I don't know much about the sixth sense perspective of it, but I think intuition comes in math through practice, and in daily life, the sixth sense part I think is more like your instinct.
Hmm.
So for me, I think the intuition part is more well defined in the mathematical aspects rather
Okay.
than the daily life aspects of things.
Okay, so I don't know when you have taken up math as a profession, but maybe you have heard what I'm going to say in your school days, maybe. So at least when my school, after we finished our class 12, school is over. None of us
Mhm.
were really good in math, because of the way it was taught or whatever the reason was. And I remember very distinctly all of us sitting together, friends, and saying that where am I going to use trigonometry? Where am I going to use Pythagoras theorem? Where is it going to come in handy? But now that I've been talking to people, it's very clear that it's even if you're not going to actively be involved, be using any of these theorems, there is a sense of disciplined thinking. There is a sense of intuition, maybe instinct. That is a very, these are very, practical toolkits for life. If you've lived a certain age, you know that these are very handy tools for life. So people and our mathematicians have added to this list, things that you can learn, things that math give you, whether you realize it or not. If you realize it, good for you. But can you add a few more things to this toolkit that math gives to you when you do it well, and then you can take it home with you and say, "Yay, life! I have this with me."
So you brought up this thing about math, the school math being useful. Can you tell me what you learned in school that you have been using in your life right now? Have you been using any
You know?
science or geography or history?
Yeah, good question. So yeah, see, geography maybe it comes up. History, not really.
But
Uh,
basic
you're
geography.
right.
Are you really using which crops grow in which soil? Are you really
No.
using
But then
what
why
kind of
why was this
plant
question
forms are there?
restricted to? Yeah, you're absolutely right. That's so interesting. But why did we pick, like, why did math become the bad guy? You know? Why was math
I
picked
think
on? Yeah.
Yeah, I think it's because of the somehow the way people approach mathematics because it requires a little more thinking on our part. You see, subjects like geography and history, you read the textbook passively and then you kind of regurgitate the information in your question paper. Whereas math forces you to think, and
Hmm.
then that's what you don't want to do, and that is why you pick on math. That, oh, what are we going to do about using mathematics? But I think whatever we learn in school, it's our formative years, and every subject has a role to play in forming our character,
Hmm.
our personality. Why do we learn history, for example? So that we learn from our mistakes in the past and don't repeat them in the future. So each subject has to come with that particular reflection of why are you learning this subject. You learn geography so that possibly you have in your mind that you visit a particular country, it's better that you know what the temperature and the climate of that country is going to be before you go there. So or rather to have an idea of the kind of world you live in, so that you don't live in this narrow kind of a thing that, oh, I live in this city and this is the only thing that I'm going to know. So similarly, math in formative school years, as you mentioned, is not only a place where you should know what Pythagoras theorem is, and you should know other formulas from algebra, etc. But it is a subject which develops your thinking,
Hmm.
and it is only through developing. critical thinking, can you apply it in life?
Right.
And only if you apply critical thinking in life can you expect your life to be a little more smoother. For
Correct.
example, I feel that several problems that we are facing today in our country or as a world would be resolved if all the people involved would sit down and think about it critically rather than becoming fanatic about it.
Hmm.
So, math, I think, teaches you not to give into emotions.
Hmm. Hmm.
Although emotional aspects is also an important in
Certainly.
math, because you, if I'm saying that math is love, or math is a sort of a relationship that I have, then there are certainly emotions involved, but it at the same time it tells you how to approach it via critical thinking
Hmm.
rather than via your emotions.
So the emotions that you're talking about are like it allows you not your emotions not to get carried away, but for you to hold your ground. Hold your ground.
Yes.
Okay, great.
Yes.
So I remember in your interview that I watched, you said that and it's obvious that school math, not just in the way it's taught, but even the subject matter is different from how, say, you start to look at math in terms of when you enter university and college. So in your interview only, you said that your love for it or your connection with it grew stronger when you realized that it's making you think,
Mm-hmm.
and that was stimulating your brain. It was making you think. So now this is another question that I've been asking mathematicians a lot. So can there be a rehaul of syllabus is very difficult. It's not easy. Systems of education come into place with a lot of thought, and they're evolving, they're degrading, they're improving. It's all a matter of time and the ideas that come forth. But do you think in school mathematics right now,
Mm-hmm.
at what age can we introduce math as a way of looking, math as a way of thinking, as a tool that allows you to think? At what age can we allow math to enter the students' minds like that it is not mindless numbers? Suddenly there's algebra, you don't know what these letters which are supposed to belong to English are now in math, and you're not even allowed to question. So maybe a format in terms of the student teacher exchange should evolve. But if math has to be reintroduced in a certain way, at what
Mm-hmm.
point, when certain basics are established, at what point should it be introduced so that children start to look at math as, it helps me here. It's not just a difficult
I,
thing. Yeah. Yeah.
I think kindergarten.
And how would you do that? How would you go about it?
I think it should be introduced via puzzles, because that is something uh, that pulls in anybody. Uh, I haven't seen anybody who has not been enamored by certain puzzles, either when they were kids or even right now.
Mm.
And that is one way that one can sort of uh, stimulate the thinking process of, let's say, a kid, and then slowly, as a method of solving more involved puzzles, you need more involved techniques, and then more involved techniques means that you need numbers, you need
Mm.
addition, multiplication,
Mm.
and these are just simply the natural things that come into picture. So I feel that there has to be a good balance of both.
Mm.
On one hand, it is, I think, important to cultivate some kind of memory associated to mathematics, like the multiplication tables, for example. I think it is important to have both. Have your very solid grounding in doing sums, addition, multiplication, etc. at that age. But along with that, also have this idea of how to solve puzzles, and only when you put them together do we have mathematics, or the way we do math at this stage at all. So I feel there is no age to introduce math. I think one can just introduce this way of thinking right from
Mm.
childhood.
Mm. So now I think we can move on a little to your teaching experience as a maths professor. So one thing I also remember from your interview is that you introduce history of mathematics, so to speak. You kind of, the coldness of the subject, you try to melt it by giving it a human aspect, saying, say, even though people who did maths, a certain kind of math that you're studying are no longer there, number one, math continues on. So there are people alive today who are contributing to math as it is growing. Plus, these people who have contributed to math, they were the interesting people in their own right, you know. So I also believe in this kind of storytelling way, and then hand holding the child and helping them enter the subject is a very nice way. They have a slight connection to the subject, and it's not just dropped from the sky and now I have to mug it up or understand it. I don't like it. It seems to have a lineage. So how has your experience been, and how did you come up? I haven't heard many mathematicians do this, that they, the Newton's theorems will come, Leibniz theorems will come, but the stories associated with this. So how did you come upon this idea, and what has the reaction been, and what has been your approach, and just the general overall experience of this?
So when so okay, there are let me break down these questions. So first of all, the idea of having this historical perspective while learning mathematics is something that I myself would have liked when I was learning. It is some, I mean, history of math or history of these mathematicians in general is something that I was interested in independent of my mathematical interest. And so when you come across a theorem of, let's say you come across a theorem of Euler, and then when you come across this thing that, hey, Euler proved a majority of his theorems after he went completely blind, then that information suddenly opens a new door to that theorem for you. So you yourself, when you have your eyesight and you're in the prime of your life, then that for you to understand that theorem is not that big of a deal, you know. And also also the learning about the certain eccentricities of these people, I think makes the whole learning process a bit more interesting. And also my PhD advisor was again very intrigued by this idea, and he has been using it in his books as well, Professor Murty. So I think he also agrees that having a certain kind of human perspective about the mathematics helps you in not only integrating it but in connecting with it.
Exactly.
Yeah, and then when I use it in teaching, I have often had only positive response. So very often there is a tendency in students then that when you come across a theorem in your textbook, then it must be something trivial. Whereas I think knowing the fact that there were mathematicians who struggled for centuries in order to come across this theorem, which is now being sort of given to you in a pre-packaged form after a lot of polishing, is in your textbook. I think that helps the student in their own research. So, for example, if that student comes across a particularly difficult problem in their own research, then it doesn't mean that they are not good enough to solve it or they can't do it. It's just that it needs time. All these development of ideas need time, and if you give it time, then things will come. And also it's just that you, let's say we cannot solve the Riemann hypothesis right now. It doesn't mean that nobody will be able to solve it, or that it is like forever some holy grail that people have to sort out. But it's probably that we have not developed the tools in order to solve that problem. For example, the Fermat's last theorem, which was solved by Andrew Weiss in the 1993 and 95. So the time that Fermat wrote it down in the margin of a book was long ago, and then people have been trying to solve that problem for centuries, and not being able to solve it should not necessarily mean that they are not good enough to solve it. It's just that the techniques that were required to solve that problem were not there
Right.
at their time.
Right.
So I think having that perspective
Hmm.
coming from the history and the development of the problem
Hmm.
and how different advances were made, and even little advances were stacked on top of each other in order to get the solution.
Right.
So although we say that Andrew Wiles is the one who solved Fermat's last theorem, it is the contributions of people before him which were also important in order
Hmm.
for him to reach his solution.
Hmm. Hmm.
So every little progress that you make is also counts. And so I think all these points put together make it really important to include the history of the problem or the life of the mathematicians involved in it. And I think it helps in making the entire subject less dry.
Right. And I understand what you're saying very well. You're saying that the students then understand that the goal is not only to solve something, but if you're contributing in creating that part of the toolkit, which can help if someone else solve it, maybe centuries from now, when you're no longer here, you've already become part of history. You've already done your bit, and that's no mean feat. That's quite a major achievement. And I think yes, if students know, and there are all kinds of students with different level of capabilities, and maybe that'll uh, keep them from inhibiting their own efforts, keeping their own
Yes.
efforts to themselves, that it's going to be fruitless. What's the point if I'm not going to solve it? But you can create that thing that can help solve it,
Mm-hmm.
right? And even
Mm-hmm.
for non-mathematicians like me, when we watch films or when we listen to mathematicians, because thanks to the internet, the age of information, today's times, mathematicians, when they come out and speak, especially when they're speaking to a non-mathematical gathering, and there seems to be growing in number, which is so nice, when physicists come and speak to people who are not from the
Mm-hmm.
background, they talk in terms of ideas, because ideas are universal. People can understand ideas. So when I hear that someone like Euler did most of the best of his math, apparently. I learned this from a film after he went blind, and his response was less distractions. Now I'll have less distractions. I mean, that leaves an impact. It doesn't have to be a mathematician to say that, but yeah, a mathematician did say that and did continue working. And that kind of gives you some kind of a strength, that here is one person. I might not understand his math, but I understand his approach, and I can adapt the approach. I can adapt the
Mm-hmm.
approach, make it a part of my own life. And you spoke of your advisor, Dr. Ramurthy. We had the privilege of having him. My husband had a wonderful conversation with him. It was very nice. And it is nice to see how after all these years, and he's also so prolific with his insights on the Indian philosophy, and how math, philosophy, apparently sciences and philosophy was once one. They were not separate branches anyway. And he is, in him, they're finding, as in many other mathematicians, they're kind of finding common ground. So talking of Dr. Ramurthy, you also said that one of the insights that he gave you was to try to understand what. I think I'll let you tell the story. You know what I'm trying to say. It was some very valuable life
Yes.
insight he gave you. And how did he? How did it come about? And if you could tell us that, then we'll take it from there.
Sure. So this is more coming from the mathematical side of things. So in mathematics we have conferences where people present the work that they have been doing and the results that they have obtained for the general mathematical audience. And then the mathematical audience takes interest in what they are doing, and then there's a series of question and answers, and that's how the subject is growing. So, apart from the solitude aspect where we do math on our own, this is kind of the social aspect of math where we talk math to each other and exchange ideas. So, what tends to happen in these conferences is the speaker who is presenting his work has been working on that problem probably for over a year or 2 years or probably more, and so is very deeply attached to the problem.
Hmm.
However, the audience to which he or she is presenting the work uh, is probably looking at the problem right then and there for the first time.
Hmm. Hmm.
So sometimes if you have been thinking about something for a very long time, there is a tendency to assume that certain things are very obvious. Certain properties are very obvious, whereas they might not be so for the general audience. It might be either that they have not had enough time to think about the problem, or it might be that they have not had enough, they don't have enough background to understand the problem. So when I was a student, I used to attend these conferences, and then I often found that in the although I am in number theory and the person who is presenting the result is also a number theorist, I came out of the talk without understanding anything that was going on in the talk. And very often, all I would catch was just words, going around. And so one day I asked my advisor, what is the point of these conferences? Because very often I go in there, I don't understand anything, and I just come out. I try to take notes, but there's absolutely nothing that is going in my head. And so that's when he told me that there is this tendency that since they have been so attached with the problem, it's sometimes difficult to disassociate yourself and then explain the question to a person who probably has no understanding or has not had enough time to think or background to understand the problem. So the best way to understand or best way to approach a talk is to try and find what is the question that the person is trying to answer. Forget about the way he's trying to answer the problem. Forget about the way he's approaching the proof or the result. What is the result? Can you try and just understand what is the question he's trying to answer? So sometimes it would be that you are in some uh, very hi-fi setup of mathematics. Like you might be working on a certain very involved, a certain thing involving a lot of definitions, a lot of language, which you don't know. However, at the end of the day, what you have is a vector space, let's say, and what the person is trying to do is compute the dimension of the vector space after you know that it is finite dimensional. So that you can understand. Okay, so this is what the person is trying to do in this hi-fi setup, which you don't know about. At the end of the day, he has a vector space that they are trying to compute the dimension of. So that any undergrad student also can figure out. And then the question is, okay, what are the techniques that he or she is using? So since you want to know the dimension of vector space, are you trying to construct a basis? Or are you trying to sort of construct a set which is a spanning set and then get an upper bound or a lower bound? And then so try and see what is the general picture of the solution rather than the nitty-gritty details of the solutions. And once you understand the general picture of how the proof is put together, the details can be figured out by looking at the paper, by reading the paper after the talk. Yeah, it's very often this general picture of how things are put together. Like the proof is supposed to be like a jigsaw puzzle that you put different pieces put together in a very coherent way. They click and they give you the proof. So even if you don't understand how exactly each piece looks like, as long as you are able to figure out how they are put together, then that gives you an understanding of, aha, this is what is going in the proof. And so then you can figure out each of these pieces by themselves later on. And so this general picture, the I think the one of the reasons that one can understand, it is important to understand this general picture is so that it may be applicable to different problems or to different situations where not where the setup is not the same, but the general idea is the same. So you might have different, let's say, different paintings on the jigsaw puzzle, but the shape of the pieces remains the same. Right. So that's why when we go into a talk, it's useful if you come out of the talk by knowing just, okay, what is the question that the person tried to answer.
Right. So it's just having that thought in your mind that let's try and figure out what question is being answered, it kind of defines your approach. And then once it defines your approach, that can be the same approach across different conferences you attend, different things that you're trying to learn. And also what I understand is that instead of starting from what you don't understand, if you figure out what you do understand, okay, this one thing I understand, maybe that is one coordinate, it can point towards this other coordinate that you can also understand. And then when you join these dots, a kind of a picture can begin to emerge, and you will be less overwhelmed, you'll be less intimidated by where you were at. So great. And have you been able to divine similar insights like this, which you've been able to pass on to your students, where you say, okay, there is this one thing that if you carry with you in your kitty of solutions, of ideas, it'll see through the day.
Um, well, I would certainly like to be able to develop this, but unfortunately, haven't had any students yet. And
But
so
you're a
I
teacher,
just,
you're a professor, right?
uh,
After
that's right. But all these ideas we usually discuss with our, let's say, PhD students. And so far I've been teaching undergraduate students.
But in terms of insights, they can also benefit from a certain insight. If you
So
tell them, think about the question that's being answered, those kind of insights, have you been able to come up with?
not to the fact that I can say, oh, I mean, I of course, I have no idea whether they have used it or not, but I usually have faced one particular general problem from students, and that has been that they feel like giving up. Uh, and something that has stayed with me and which I keep on telling them is to just stick with it and you will get through. So the one insight that I think I have passed on to the students that I have had is this, that if you're going through a rough phase in your let's say you're trying to understand a paper or you're trying to solve a problem, and there is a phase in which you seem to not be making any progress at all, and in such a phase it is very easy to feel that you want to give up because there is nothing that is progressing. I think in that phase, if you just stick with the problem or stick with the paper or just even if nothing is progressing, keep on uh, going with it, eventually a certain crack will emerge, and then things will open up, and then you will get that one ray of understanding.
Wow.
But it's like if you give up in the middle, then you don't know what was going to happen. Then you don't know if you could have had that
Right.
understanding or not.
Have you heard of the singer-songwriter, Canadian singer-songwriter, Mr. Leonard Cohen? Have you heard of him?
No,
So
no.
he's no longer with us, but he was very wonderful. Maybe you've heard some of his songs. And he had a very wonderful line. And he said, there's a crack in everything. That's how the light gets in. And these
Uh-huh. Uh-huh. Exactly.
something goes
Yes.
goes in the same lines that he was saying. Yeah. You also teach some students in your hometown in Nasik, or I don't know if you were doing that, if you're still continuing to do that, and are you still doing it?
So I came back to India in August 2021, and so since then I haven't had a chance to talk to school kids in Nasik. But I
Okay,
used to do it when I was doing my undergrad or even later whenever I visited.
sure.
But
So you did.
not in recent times.
Sure, no problem. But I think the question still stands. Like you were doing something what you called as non-routine mathematics with them, non-routine mathematics. And so I would like to know, and maybe this can be one of the, if not the last question, maybe one of the last questions. It's been some time. Um, what is non-routine mathematics? And if you could create an image of the kind of response and approach and feelings that the students, the school students, right, had towards mathematics. What was your experience about all these things?
So non-routine mathematics is something that I myself did when I was a child. So by non-routine, I just mean something that is not in the textbook, in the school textbooks.
Hmm.
So this is precisely what I was alluding to in the beginning, that it is trying to make you think in solving problems, wherein you don't need to just okay take a formula, put in numbers, and get the answer. It's not just that. It's a problem where you have to put in thought on how to solve the question, and then there is a certain sort of challenge involved
Hmm.
in coming up with the solution.
Hmm.
So I was exposed to doing this kind of mathematics through uh, these through certain extracurricular exams that I used to give in school. And various agencies or various organizations were there that would keep these kind of exams, I think from fourth or fifth grade all the way to 10th grade. It was through solving problems and preparing for these exams that my love for mathematics developed. What I was trying to do with the school kids back is try to give them back what I learned, and try to kindle the joy of mathematics in them through the same way that it did for me. And I think the response that I had was spectacular. I think there are these kids who really pick up on this problem solving approach very fast. And then since it's the school time, you can there is a sense of competition there, where they really want to show it, oh, I can do it, and there's no problem that can stump me, and I'm on the top of the world. That sort of an approach. And I think that that innocence and that driving force really helps them to connect with it. And I think that is something that should be provided to all school students. It may happen that not everyone picks up on it,
Hmm.
but certainly those who are interested, I think, will be quick to catch on to this kind of challenging problems, and then learning mathematics through solving problems approach.
Right. Any final words about the essence of math?
The essence of math, I think you will get it once you do it.
Has you've done
So,
it, so anything
uh,
that it is revealed to you?
sure, but I would invite you to do it and then find out the secrets.
That's a long wait.
No, but I think that is one of the points that as others would have also said, I'm sure, that math is for everybody. Similarly, like, art and music is also for everybody. So I feel that in order to truly appreciate the joy that math gives, it is essential to do mathematics. And it doesn't mean that you need to, now pick up some research tome on number theory and then go through it. No, not at all. I mean, math can be enjoyed in the very simple um, puzzles and problems that one can come across in life. And just because you don't write down a formula and you don't do some algebra doesn't mean you're not doing mathematics. So there's this wonderful book by a Russian author, I forget his name. It's called Mathematical Circles.
Mhm.
It has different levels of puzzles. It starts from level 0 and then introduces several different concepts in math with increasing level of puzzles. And I would recommend that book to everybody all over. And it was one of the books in my childhood which really motivated me to take up math. And so I would really recommend that. And I would invite everyone to come in and enjoy mathematics. And that's how we all would probably, uh, I think, develop as a race. And hopefully, we will stay away from any further world wars.
Good note to very good note to end this conversation on mathematics, Dr. Pathak. Thank you once again for your time and for your wonderful way of explaining yourself. Thank you.
Sure, sure, no problem. Thank you for inviting me. It was a pleasure talking to you. And if you have any questions, even apart from this conversation, or just questions about math or life, please feel free to contact me. I don't know how much help I can be in terms of the life part, but the math part, I certainly think that I'll be of little bit of help.
Wonderful. My conversation with Dr. Pathak helped me think of maths as music and as an art form. Like them, maths too is all about underlying structures and patterns that reveal their true beauty to the persisting mind, and that this beauty can inspire insights that can make life a beautiful experience in itself. It will be wonderful to know your thoughts on the interview and if it inspired your worldview in any way. Thanks for being here. I will see you soon with another interesting mind demystifying another interesting subject. Until then, take care.